Okay, so in this video what I'll be doing is going on both the polluter and auditor participants together, because they kind of work together and it doesn't make sense to make two separate videos to show how they work. So yeah, so let's view the auditor profile. I've created an auditor here and I've added a few members to its supply chain already. I've added polluter 1 and polluter 2. Okay, the auditor can view these two accounts but can't make any changes to the balances of these accounts, and those changes can be made only by operator through the smart contract stored on it. And I've created two polluter participants along with that, polluter 1 and polluter 2. Okay, so if we see polluter 1's profile, it already has a balance of 9.9. I've assigned it for the sake of this video, and we can view its certificate which was already cashed in. Okay, and for polluter 2, let me just switch to that. It doesn't have a balance. It had a certificate. I had submitted a certificate for it which was cashed in, but then I kind of change the value of that account for the sake of this video. So we'll be submitting a certificate for assigning a certificate to polluter 2 using the auditor's account. So let me show you how it can be done. You can add a certificate for polluter 2. Let the certificate ID be, suppose, and the value be, suppose, 10 tons of carbon, and the description could be quota for this month. Okay, just submit this. Okay, it's been submitted. We can view that certificate. This is the certificate we currently created. It's created and needs validation. Okay, and if we go to polluter's profile, we can again view the certificate that this certificate has been assigned. Okay, now to validate this certificate, similar to the certificate of the cleaner, we'll have to run a smart contract which is stored on the operator account. So let's just validate this certificate. We just pass it the certificate ID. Okay, so for the polluter, we actually don't need any IoT based verification anytime, because this quota has been assigned by its auditor, and within the supply chain this quota is just for adjusting tokens whenever required in the future, and I mean it does not have any significance outside the supply chain. So yeah, and what this validate certificate smart contract checks is whether a similar certificate has already been submitted, which is being reused inside the business network, and if that is not the case, then it will be given as valid. So if we see polluter 2's certificates, the status is now changed to validated and accepted. So now let's cache in this certificate. So to cache it in, again from the operator account, we'll go to tokens, to assign tokens to polluter, and give it the certificate ID and polluter ID, and okay, so let's just see. Yeah, so the balance has been updated. As I had said, I've kept the exchange rate or conversion rate as 1 token is equivalent to 100 tons of carbon. So the certificate value was 10 tons of carbon, which corresponds to 0.1 token. So that's what is being updated here. Okay, so I'll show you how auditor can report this report the carbon consumption of this polluter to the operator. So we just go to the auditor account and submit a usage report, report usage, and for polluter 2, and let's keep the value as again 10 tons of carbon. Let's make his balance 0. So let me just submit this report. Okay, and I've submitted for polluter 2. So if I view usage report, yeah, I had already submitted one before, but yeah, even this report is of the same value. So let me just copy this report ID. I'll need it to burn tokens. So the operator can view this report and burn tokens. So let me show you how it's done. I'll switch over to the operator and the burn token smart contract. Just paste in the report ID and submit this contract. So what we could do is whenever a report is submitted by the auditor, just fire the smart contract, and here is where we can use sensors and IoT devices. So what we could do is track the electricity consumption of cleaners, of polluters, and their fuel consumption. Maybe a truck is going around doing deliveries, so track how many kilometers it travels, what kind of fuel it uses, and what amount of carbon it uses, and maybe track carbon used in other such processes, and submit reports using the report usage smart contract. And then whenever that smart contract is submitted, fire the burn tokens. The operator will fire the burn tokens smart contract on the corresponding report, and that amount of tokens will be burned. So let's just head over again to polluter 2, and if we view its user profile, like its balance is 0 because we burnt all his tokens. So what can the polluter do now? So he has two options. One is ask the auditor for more credits from within the supply chain, which will be met. That requirement can be met by the auditor. So what the auditor will do is run the adjust credit smart contract, which will examine if those tokens can be adjusted in such a way that the net amount of tokens still remain same and all the requirements of the smart contract are met. I've kept a requirement that the value of the request should be at least less than twice the amount of tokens in the polluter's account to transfer that. So if that requirement is met, then those credits can be transferred. Another option which the polluter has is order more credits from the cleaners. So basically offset carbon, your carbon consumption by buying credits from the cleaner. So let's see how I've actually created a request already, which has a request ID this and a value of 4 tokens. So I'm telling the auditor that if you could give me 4 tokens, that would be good. So the status here is incomplete. So let's just copy this and head over to the auditor dashboard and adjust credits. Okay, and just paste this request ID here. Okay, and then submit this. Okay, so what this will do is it will examine whether the supply chain can transfer the requested amount of tokens to the requesting party, and then the transfer of token actually is done by again the auditor by assigning tokens to the polluter. So the auditor cannot actually alter the balance of his account, but the facilitation of tokens, that I mean, it can specify what amount of tokens need to be transferred to the auditor, to the operator, and then the operator will execute the smart contract to actually assign those tokens and readjust those balances. So if this was successful, let's head over again to Polluter 2's profile, and you can see balance is 4. So where were these tokens coming from? Okay, so if we see Polluter 1's balance has been reduced by 4 tokens. So Polluter 1 basically had sufficient amount of tokens to transfer to Polluter 2. So that's what happened, internal transfer within the supply chain, keeping the net amount of tokens the same. So now if I again submit a request for 4 tokens and the balance is 5.9, which is not twice the amount of the request, so that smart contract just won't go through. So what other alternative does the polluter have? As I described earlier, you can order credits from the cleaner. So we'll submit an order for credits, which is for polluter 2, and then value is suppose 10 tokens, and let's submit this. And view your orders here. Okay, the status is incomplete. If you view the request, the status is completed. Once a request is completed, that cannot be again submitted. That's the kind of logic that the smart contract abides by. So yeah, we have submitted an order. So let's see how we can match this order. I mean, we can fulfill this order. So for that, I need to go to the operators account, and there is a smart contract called as match orders. Let me just see if it shows up. Yeah, match orders, and you have to give the order ID. So just copy this here and match orders, and what it will do is it will query the token accounts of the cleaners inside the network and facilitate that amount of tokens if there are sufficient tokens within the business network. So this is where offsetting comes in, that you are offsetting your carbon consumption using someone else's captured carbon. So if we head over to the polluter 2's account, now okay, this status has been changed to completed. So let's see if, yeah, the balance has been incremented by 10 tokens. Now where did this 10 tokens come from? Okay, so I had created a cleaner earlier, and if we see its balance, it was before executing this contract, its balance was 1001. Just refresh this to get the current balance. Yeah, it has been decremented by 10 tokens. So basically this cleaner traded its tokens to the polluter, and the cleaner will get whatever the value of those tokens is back in his back as currency, fiat currency, as for selling those credits. So what happens is, without actually knowing each other, polluters are able to offset their carbon using credits, credits for capturing carbon that have been submitted by cleaner. So this is how the solution works, and yeah, that's about it. So one last note, Both Hyperledger Fabric and Hyperledger Composer, the instances that I have used are running on Microsoft Azure virtual machines, which I had set up earlier, and all the entire application is running on them. So yeah, and all the peers, all this data is being sent to a distributed system. So basically, even if this is which makes it more fault tolerant. So even if there's a crash of data somewhere, that data, I mean, if there's a failure somewhere, that data won't be lost because it's distributed on multiple machines. So yeah, I think that was it for this application. So this was the B2B carbon trading application that we have built using Hyperledger, the Hyperledger project, the Hyperledger Fabric blockchain, which can be used to facilitate different actors to trade the captured carbon and offset the carbon, and pretty much that's about it.